All right, in this video, we're going to begin by investigating transformations. Now, the key thing to understand with the transformation for right now is that we're going to be putting things in this format. Now, when you look at that format, x minus h plus k, h is referring to how the graph is affected horizontally. K is referring to how the graph is affected vertically. So anytime we refer to a translation is a certain type of transformation. So if you think of what the word transformation means, a transformation just means change. Like think about the movie with Transformers. Transformers are robots that change into vehicles or other things. And so that's what we're referring to. A transformation is referring to a change in our graph. And one of those changes is a translation. And a translation means that we're going to be moving it left, right, up, or down. Okay, that's in essence, that's what we're going to be looking at in this first part of the video. So let's look at this first example. It says, what is a function of g of x after a translation of 3 units down from f of x equals x? All right, so we have this thing in function notation. So we have our equation in function notation, f of x equals x, and we're going to come up with a new equation, a new function, g of x, that's going to represent moving it 3 units down. So down refers to a vertical translation. So that means we're just going to tack on what's happening after the function. So, whoops. So g of x replaces y, by the way. So g of x equals, so we have x, and then we're going to go 3 units down. So that would be x minus 3. So now it says graph both functions for that domain from -2 to 2. And we want to figure out how are those domain and ranges related. So what this domain means from -2 to 2 is we're just going to create a table of values. And this just means pick the numbers between -2 to +2. Now when we do that for f of x, which remember is just f of x equals x, our input values are x. When we put those in, our answers are going to be the same. So when I input -2, my answer, my output is going to be -2. When I put -1 in here for x, I get that my answer is going to be -1. Nothing changes. When I put 0 in there for x, again, nothing changes. So this is what we would get. And now let's do that for g of x. Now g of x is telling us to apply this to our function. So when we do the same domain, when we plug those numbers in for x, we put -2 in there. -2 minus 3 is -5. When we put -1 in for x, -1 minus 3 is -4. Put 0 in there, you get -3. You get the idea. And these are going to be the points we're going to graph. So let's graph both these functions. Let's start with f of x. f of x, when I graph that, we're going to graph the point -2, -2, -1, -1, 0, 0, 1, 1, 2, 2. So even though those are the only points we graphed, this goes infinitely in both directions. All right, let's do the other one, function g. So we're going to have -2, -5, -1, -4, 0, -3, 1, -2, and 2, -1. So the domain and range of these are the same. So the domain for both of these, if we were to squish it, goes on the x-axis. We'd end up getting -infinity to infinity. Our range for both of these, if we squish these on the y-axis, would also be from -infinity to infinity. But you can see that this red graph has been moved down. Each of those coordinates have been moved down 3 units, which is what we wanted to accomplish. Let's look at this next example. So it says, what is a function for g of x after translation of 3 units to the right of f of x equals x squared? Now, let's go back up here. Inside of our function here, whatever happens horizontally it's always going to be the opposite of what we would expect. So if I replace h, if we're going to go to the right, oops, we're going to go to the right 3 units. Let me erase this, hold on. If we're going to replace h with 3, notice what we would have there. We would have x minus 3. Okay, so that's what would happen. If we put 3 in there for h, we'd get the equation x minus 3. Specifically for this one, it's x minus 3 squared. So that's what happens when we move it to the right 3 units. I might say, wait a minute, if I move it to the right 3 units, wouldn't it be x plus 3? Here's what I want you to remember. Whatever happens inside our parent function, what the heck's a parent function? We haven't talked about that yet. A parent function is what we have here, y equals, or f of x equals x squared. That is one parent function, meaning that all the other equations that we could add, or all the other values that we could add to this, is all going to be based on this equation y equals x squared. So that y equals x squared, or f of x equals x squared, is a parent function. Up here, this is a parent function for a linear equation. So meaning anything I do to that will always be based on this original parent function. What did we graph there in blue? Okay, so we're looking at a few different parent functions in this chapter. So our first two parent functions that we've seen are a linear equation and our quadratic equation. So a quadratic is y equals x squared, so that's another parent function. All right, so we're going to graph the original function. Again, we'll do that, f of x. We're going to graph that one using table of values going from -2 to 2. So when we square those, that's what we're going to do here. We're going to square those values. When we square negative, it becomes positive. So -2, when you square that, becomes a positive 4. -1 squared becomes a positive 1. 0 squared stays 0. 1 squared is just 1. 2 squared is 4. So now let's come up with a table of values for g of x. So now we're going to use the same values, -2. Whoops, what happened there? -2, -1, 0, 1, and 2. So now we're going to put these numbers in for x, subtract 3, and then square it. So -2 minus 3 is -5. Let's square -5, we get 25. -1, when I square that, -1, or I'm sorry, not squared yet. -1 minus 3 is -4. When I square -4, though, I get a positive 16. 0 minus 3 is -3. When I square that, I get 9. 1 minus 3 is -2. When I square that, I get 4. 2 minus 3, -1, is -1. When I square that, I get positive 1. Let's start with the blue graph. So we have -2, 4, -1, 1, 0, 0, 1, 1, and when x is 2, y is 4. Now with our red graph, the problem is -2, 25 doesn't even fit on our graph. In fact, it's not until like even 0, 9 doesn't fit. It's not until we get to when x is 1, y is 4. When x is 2, y is 1. Now if I continued to pick points in our table, our graph would look like this. Let's see if I can do that a little better. Here we go. That looks a little better. So again, you can see that this graph has been moved to the right 3 units. So even though it said x minus 3 squared, our brain wants to say, ooh, x minus 3 must mean to the left, or we need to do the opposite. So what happens inside a parent function, it's always the opposite of what we expect. What happens outside a parent function, so like if let's say I were to have something like this. So this plus 5 is outside that parent function. That affects the graph vertically, and that happens exactly as we see it. So that would mean it would move that parent function up 5 units. So here's what I want you to try on your own. I want you to try this first one. So this is, we have the equation y equals x squared. I want you to figure out what would be the equation that would translate the graph 3 units to the right and 4 units down. Do your best on that. I know that might be a little bit too much at first, but I just want to see what you can do on your own. And this next one, what would be the equation for the absolute value function graph below? Now, absolute value, that's another parent function. Looks like this. Okay, so we want to come up with an equation based on this parent function that would give us this graph. Now, what does the graph of the parent function look like? So y equals absolute value would look like this. So I want you to figure out what would be the equation that would move it this many units to the left and this many units down. So again, do your best to see if you can figure that on your own. If you don't know, just wait a second and I'll explain it to you. All right, trying to erase that, but let's look at that first one I wanted you to try. Okay, so that first one for 1C, it said what would be the equation of y equals x squared? We'll translate 3 units to the right and 4 units down. All right. So what happens outside the parent function is going to be what happens to the graph vertically. So let's actually start there. So it's 4 units down. So that would be minus 4. Okay, so that's exactly as we see it, 4 units down, it would be minus 4. That's going to be anything that's vertical happens outside the parent function. Whatever happens inside the parent function, that's going to affect the graph horizontally, and it's always going to be the opposite you'd expect. So if it's 3 units to the right, I would not say plus 3, I would do the opposite. I would say minus 3. So y equals x minus 3 quantity squared minus 4 would be a parabola that would be moved 3 units to the right, 4 units down. Don't believe me? Go ahead and graph it on your graphing calculator. All right, let's look at this other one. So this other one, we have this original parent function, and we have this new function. So this one we move to the left 2 units and down 5 units. So if it's to the left 2 units, it's going to be the opposite. It's going to be x plus 2. And if it's going to go down 5 units, it's exactly as we would expect. It'd be minus 5. So that would be the equation for that other function there. Y equals the absolute value of the quantity, x plus 2 minus 5. All right, so that was a translation. Now let's talk about a reflection. A reflection, we could have a reflection across the x-axis or across the y-axis. So a reflection across the x-axis, that's going to look like this, where you notice the difference here between the original function and this other function is that the output switch signs. And the result is that it's going to be a vertical flip. That means it's going to be flipped vertically. And the difference between these two, so you can see that our input is the opposite. So the input switches signs here. And what that's going to mean is that's going to create a horizontal flip. So let's see how we can use that in this example. So here it says, graph a reflection of f of x equals 2x minus 6 across the x-axis. So what that means is that if it's across the x-axis, it's going to be flipped vertically. Because remember, this is our x-axis, this is our y-axis. If I'm going to flip it across the x-axis, let's just pick some points. I'll just pick these 3. And what we're going to do is we're going to flip those over the x-axis. So if I take this point, and if I flip that over the x-axis, so this point is 4 units below the x-axis. So now I'm going to flip it so it's 4 units above the x-axis. This one is 2 units below the x-axis, so I'm going to flip that to be 2 units above the x-axis. And this one is 4 units above the x-axis. We're going to flip it to be 1, 2, 3, 4 units below the x-axis. And if you connect those, that's what our line would look like. Okay, let's look at this one. Let's pick the same points as we did before. Oops. But this time we're going to flip it across the y-axis. By the way, we'll get to what the equations would be in a second. But we're going to flip this one across the y-axis. So if we're going to flip it across the y-axis, I'm going to take this one that was 5 units away from the y-axis. Now we're going to put it 5 units on the other side. 1, 2, 3, 4, 5. That'll be right here. So this point here is 2 units away from the y-axis, flip it over 2 units on the other side of the y-axis. This one's 1 unit from the y-axis, flip it over so it's 1 unit on the other side of the y-axis. So now I can connect those. Oops, I don't know what happened there. Let me fix that line. There we go. Yeah, that's better. Okay, so that's what our graph would look like if we flipped it over the y-axis. Now, what would the equations be if we flipped it over the x-axis and we flip it over the y-axis? So one way to do that would be to use what we just learned up above here. So this first example is a vertical flip. Okay, so this, referring to what we have here. So what we're going to do is we're going to take the opposite of the output. The output switches signs. So it's like we'd have negative. Well, let me do it this way since we have. So we'll have negative y equals 2x minus 6. So 2x minus 6 is the original function. I want to get rid of this negative that's in front of the y. So what I'm going to do is I'm going to divide both sides by a negative 1. So that'll make that y positive. And when we divide all of this by negative 1, 2 divided by negative 1 would be negative 2x. Negative 6 divided by negative 1 would make that a positive 6. So the equation would be negative 2x plus 6. Or for this other one. This other one was a horizontal flip. We flipped it horizontally, flipped it over the y-axis. And so if we do that, our input is going to switch sides, or switch signs. So instead of being x, it's going to be negative x. And if I simplify that, that would just become negative 2x minus 6. So that would be our new equation for that blue line. If you check, remember our slope-intercept form. So this new equation is saying our slope is negative 2 and has a y-intercept of negative 6. Sure enough, this blue line has a slope. We can go down 2 over 1. So it's got a slope of negative 2, and it has a y-intercept of negative 6. All right, we're going to stop there. We're going to do vertical stretches and compressions. We're going to combine that with horizontal stretches and compressions in our next video. So we will stop there with this first lesson for lesson 1, 2, part A.